Hi, good day everyone. So in this video, I will be presenting the firefighting system and electricity supply system available in the quantity surveying department building at UiT and Perak branch. The purpose of this presentation is to identify the safety features installed in the building and to understand how electrical energy is supplied and distributed. So first is fire extinguisher. Inside the quantity surveying department building, portable fire extinguisher are placed at strategic locations such as at corridor, near classroom, and at emergency exit road. Most of them are dry powder or CO2 extinguisher designed to extinguish electrical fire and small combustible fire. So the second is fire hose reel. Near the main entrance and some corridor, fire hose reel are installed. These are connected to the building water supply and used for large fire. The hose reel allows occupants or trained personnel to control fire during the early stage before the fire spread. The building is equipped with a manual fire alarm. Breakless call points are located along emergency roads. When activated, the alarm triggers a loud siren to alert all occupants to evacuate immediately. Emergency exit and signage. Clear emergency exit signage with illuminated light is installed throughout the building. This sign guides occupants toward emergency staircases during evacuation. The building also has fire evacuation plans displayed on notice board. Fire hydrant outlet. The fire hydrant outlet provides a high-pressure water supply for firefighters during an emergency. Fire engines will connect their hoses to this hydrant to pump water quickly and effectively to extinguish a large fire. Electric room. An electric room is a dedicated space in a building used to house all the main electrical equipment. It must be restricted because the voltage in this room is very high. Only trained technicians are allowed to enter.
As a future quantity surveyor or construction professional, the roles that I might be playing in promoting sustainability when dealing with mechanical and electrical system in a building is promoting energy efficiency. One way to promote energy efficiency is to select energy-saving equipment. For example, we can change from incandescent bulbs to LED lights, normal air conditioner to the efficient air conditioner, and the last one, which is we can change from conventional tap to self-closing tap. By using any of this, it may cost initially, but they will save money through lower electricity bills.
So now we will move on to the next question. Explain why it is an ethical responsibility for building professionals to promote sustainable practices in mechanical and electrical known as M&E system. Provide one example. It is an ethical responsibility for building professionals to promote sustainable practices in mechanical and electrical known as M&E systems because their work has a profound long-term impact on the public safety, health, welfare, the environment, plus the ability of future generations to meet their own needs. Building professionals in Malaysia have an ethical obligation to promote sustainability for several key reasons. The first one being public welfare and health. Professionals have a duty to protect public health and safety. Unsustainable M&E systems contribute significantly to poor indoor air quality, thermal discomfort, and reliance on energy sources that cause air pollution, which directly impacts the well-being of building occupants and the surrounding community. Moving on to the next reason is responsible to future generations. Sustainability is defined as meeting the needs of the present without compromising the ability of future generations to meet their own needs. Building professionals have a moral obligation to act as responsible custodians of natural resources and the environment for the long term, avoiding actions that cause irreversible future harm. I would like to give an example. The scenario given is a building professional is designing a large commercial building which contains heating, ventilation, and air conditioning system. They have two options. One, a conventional system with lower upfront costs but high energy consumption and operational expenses. Number two, a ground source heat pump, known as GSHP system that costs more initially but offers substantial long-term energy savings and a much lower carbon footprint. From the scenario given, the professional ethically advises the client to install the GSHP system, which is the second scenario. They use data to demonstrate the long-term cost savings, reduces environmental impact, and enhances building value. This choice prioritizes the long-term well-being of the planet and future occupants over short-term and financial pressures, aligning with the professional's ethical responsibility to observe the principle of sustainable development. That is all from us. Thank you.